Hi there, and welcome to Olago Academy. For today, we are considering a topic which is molarity in chemistry. Now, molarity is one of the simple topics in chemistry, but it requires your approach to the topic. So, without wasting much time, let's define what molarity is. Now, molarity is simply the amount of a substance or the amount of a solute in a certain volume of solvent. That is molarity. I repeat, molarity is the amount of a substance or is the amount of a solute in a certain volume of a solvent. So that is the definition for molarity. Another thing we should take note of is that molarity is the same thing as concentration. So when I say molarity, I'm also referring to concentration. Molarity and concentration means the same thing. So from the definition of molarity, we are saying that mathematically, we are saying that molarity, I can represent it with M. So we are saying that molarity equal to the amount of substance or solutes in a certain volume of solvent. So from the definition of molarity, we are saying that molarity is the amount of a substance or the amount of solute in a certain volume of a solvent. From here now, amount of substance is being represented by mole. So we are saying molarity equal to mole over volume. And remember your fundamental quantity. Remember that we have 7 fundamental quantities. We have 7. We have mass, we have electric currents, we have temperature, we have time, we have amount of substance, we have length, and we have luminous intensity. So we have 7 main fundamental quantities, and one of them is amount of substance. So the fundamental units for amount of substance is mole, which is mol. So we represent amount of substance with mole, which is mole, but the unit is mol. So we have molarity to be equal to mole as a fundamental unit over volume. So we have this. Alright, from here now, we can say that molarity equal to the symbol for mole is M, small letter M, and the symbol for volume is V. So we have this. So we can say that molarity equal to number of mole over volume. So we have this here. We have this. Alright, so we measure mole, in mol and volume in dmq. So we have this. We measure molarity to be equal to mole over volume. So we can say that the SI unit the SI unit of molarity is what there? Mole per dmq. We can have this as mole per dmq. So we have this. Remember that we started from molarity, the definition. So we have this as the definition. We said that amount of substance is what? Is mole. That's amount of substance. So we have mole over volume. So for mole, the fundamental unit is mol. For volume, we have it same as volume. So we said that the symbol for mole is small letter n, and the symbol for volume is capital letter V. So we have this here. And we said that mole, we measure mole as mol, and we measure volume in dmq. So this gives us the SI unit for molarity. So we what? Mole per dmq. So we have SI units to be what? Mole per dmq. Or we can have our mole per dmq written as this here. Alright, so we have this. And one other thing you take note of is that we can have concentration also. You can have concentration also. You can have our concentration also to be equal to what there? N over V. You can have this. You can have this. You can also have molarity to be equal to N over V. So you can have either of these two. You can represent molarity with concentration, and can also represent molarity with ordinary N as the molarity. And before I forget, one thing also we should take note of is that we can have the SI unit of molarity as mole per dmq, or we can have it as molar. We can have it as molar. Molar is this. This is molar. This is molar. So represents molar with N. So if I say that 3 mole per dmq, and I say that 3 molar, I mean the same thing. They are both the same thing. 3 mole per dmq is the same thing as 3 molar. I have this. Alright, so that should be noted. The SI units can be mole per dmq or can be molar. So I have this. Alright, so now we are having concentration to be equal to number of mole over volume, or molarity to be equal to number of mole over volume. You can add this. From here now, we can derive a formula. I can make this n here to stand alone by cross multiplying. So n times 1 will give me n equal to C times V give me CV. Can add this. From here, on the account of 2 concentration, on the account of 2 volume, I can have this, that C1 V1 equal to C2 and V2. I can have this here as one of my formula for calculation when it comes to molarity or concentration. Alright, same thing applies for M as molarity also. I can make this N here to stand alone also. I can make this N here to stand alone also by cross multiplying. So if I cross multiply, n times 1 will give me n to be equal to nv. So on the account of 2 molarity and 2 volume, I can have M1 V1 equal to M2 and V2. I can have this. We call this one dilution formula. You can call this dilution formula. I've made a video on, in that video, I made use of this dilution formula to solve like 2 questions. Alright, so to take it out, the title is using dilution formula to solve questions. I think that was the title. So we have this as our formula when it comes to calculating concentration. So we can use this. We can also make use of this here. Alright, so we have this as our formula for calculating molarity. Now we have another formula that we can make use of when calculating concentration. We have another formula that we can make use of. So we have the formula for molarity. So it will also be equal to molarity is also equal to 1000 times W over mm multiplied by V. So we can have this also as the formula for calculating molarity. 1000 times W over, this is molar mass times V. So we have this here. So we have this. So let's define these parameters. I'm taking this I off so I can define these parameters here. So we have this that M equal to 1000 multiplied by W over mm multiplied by V, where M is equal to molarity, W equal to weight or the mass of solute, and we have mm as the molecular mass, and we have V as where V equals to volume, so we can have this, and volume in dm3 or can be in liters. So 1 dm3 is also equivalent to 1 liter. So we can have this. So we have this formula to make use of. We also have this formula to make use of. And we can also make use of this formula when it comes to calculation in molarity or concentration. So let me list out the formula that we have. So we have this. So we have, okay, alright. So we have these formulas here to make use of when it comes to molarity. So do well to jot these formulas down. So let's proceed to solving calculations under molarity. Alright, question 1 now. Question one says that you are provided with a 3 molar sodium hydroxide solution, full stop. Calculate the volume of this stock solution which must be added to a flask to make a 0.1 molar solution when diluted to 250 milliliter. So let's see how we can solve questions like that. As usual, the first thing to always do when we see a question, let me see calculation in science subject like physics or chemistry, the first thing to always do is to list out our given parameters. So solution now given. Now let's see what we are given in the question. The question says that you are provided with a 3 molar sodium hydroxide solution. So we are given molarity there. Molarity will be 1 there, 3 molar. So we have this. Full stop. It goes further. The question goes further and says that calculate the volume. Calculate the volume. So volume is appearing. So we have volume to be equal to question mark. Calculate the volume is already there of this stock solution, which must be added to a flask to make a 0.1 molar solution. So as you can see that molarity is also appearing again. So we have molarity to be equal to 0.1 molar solution. 0.1 molar solution when diluted to 250 milliliter. So that parameter, having that milliliter, is volume. So we have volume again to be 250 milliliter. So we have this. And converting this to liters, that will be 250 divided by 1000. 0 cancels 0. So this becomes 0.25 because we are having 20 here, bringing the decimal point two times to this side. It goes like this, 1 and 2. So here we are having 0 comes 0 points. So we have 0.25. So we have 0.25 liters. So we have this. Alright, since this one is our first molarity, it becomes our M1. And this one is our first volume, it becomes our V1. This one here is second molarity, so it becomes our M2. And this one is our second volume, so it becomes our V2. Alright, from all the formulas that I've presented in this class, what formula is the best formula to make use of? It is what? M1 V1 equal to M2 V2. So recall that we are having M1 V1 equal to M2 and V2. We have this. And since we are looking for V1, you can decide to divide both sides by the coefficient of V1, which is M1. So it becomes over M1 over M1. So M1 cancel out M1. So we are going to have V1 to be equal to M2 V2 over M1. So we have this here. Alright, so let's continue the calculation. From here, we are going to have this. From here, we are going to have this. So let's impute the values for the parameters here now. So V1 equal to M2. M2 is what? 0.1. So we have 0.1 multiplied by V2 is what? 0.25 liters. We have 0.25 liters over My M1 is 3 molar, so we have 3 here. So we have V1 equal to, if we multiply 0.1 times 0.25, we are going to get 0.025. So we have 0.025 over 3. Now, 0.025 over 3, we are going to get our V1 to be equal to 0.0083. 0.0083 liters. We have this as our final answer. If you press your calculator, you can get 83 times 10 raised to the power minus 3. So you can have this. So if you have this, it's like you are bringing the decimal points this side 3 times. So you can have this. You can have 8.3 times 10 to the power minus 3. So you having 8.3. So minus 3 means you are bringing the 0 at this side 3 times. So we are going to have 1, 2, and 3. So per this one here, we are going to have 0. So we can have 0, 0, another 0 here. So what happened there? We can have decimal points here. It becomes 0.0083. So from this, we can have this. Alright, that is how we can solve question on molarity. So you can solve question using this formula here in molarity. So let's see yet another question to calculate. Alright, example 2 now. So question 2 says that what is the molar concentration of a solution containing 10.0 gram of sodium hydroxide in 250 milliliter solution? So let's solve that question. As usual, let's list out our given parameters. So given, what and what are we given in the question? The question says that what is the molar concentration? So molarity is another word for molar concentration. So that is question mark. So if they ask us that what is the molar concentration, it's the same thing as them asking you what is the molarity. So from the question, molarity is not given because it says that what is the molar concentration. So let's continue. Of a solution containing 10.0 gram. Now, take note, the parameter having gram as its SI unit is mass. So we are given mass in the question, that is small letter m, to be 10.0 gram. So we have this 10.0 gram of sodium hydroxide in 250 milliliter solution. So from the question there, we are given volume. So volume is given to be 250 milliliter. So we have this. Alright, from here now, from the formulas that I've given so far, what formula is the best formula to make use of here? If we are going to use if we are going to use M1 V1 equal to M2 V2, in this case here, it cannot work because we are giving mass. If you can use C1 V1 equal to C2 V2, it cannot work here we are going to make use of C1V1 equal to C2V2. It can also not work. It cannot work here. But the formula that can work here is what here? Molarity equal to 1000 times what? Weight over molar mass times volume. And the question is that, are we giving molar mass? We are not giving molar mass, but we can find the molar mass because we are giving the substance to be sodium hydroxide. Sodium hydroxide. So now let's calculate the molecular mass of sodium hydroxide. Alright, so we are having sodium hydroxide. The atomic mass of sodium is 23. That is the atomic mass of sodium. The atomic mass of oxygen is 16. And lastly, the atomic mass of hydrogen is 1. So we have 1. So all together, we have 40. We have 40. We have 40. If it is molar mass, you can add units to be gram per mole. If it is molecular mass, it has no units. So the molecular mass, or let me say the molar mass, is 40 gram per mole. So we have this. So let's recall that molarity equal to 1000 multiplied by weight or mass over molar mass multiplied by volume. And one thing to take note of here, I just said that earlier, but just take notes. If the question, if the volume in that question is coming as cm cube or milliliter, make use of 1000. Make use of 1000. But if you convert to maybe from cm cube to dm cube, you will not use the 1000 here. And if you convert from milliliter to liter, it means that you are not going to use the 1000 here. Now, what do I mean by that? So let's solve this. Let's see how we're going to apply the formula here. So from here, I'm going to have this. I'm going to have this. So molarity equal to, since I'm making use of milliliter, I'll use the 1000 here. So I have 1000 multiplied by the mass, or the given mass is 10.0. So we have 10.0 over the molecular mass, or the molar mass, is 40. We have 40 multiplied by the volume is 250. So we have 250. So we have this. So 1000 times 10 will give us 10,000. 10,000. 40 times 250 will give us 10,000 also. So we are going to add this. If we divide this, 10,000 here 1, 10,000 here 1. So our final answer is 1. 1 what? 1 molar. 1 molar. So we have it as our final answer. Our final answer. Now let me say that I convert from milliliter to liter. I'm not going to make use of this 1000 here. So let's see how I'm going to apply the formula here. Let's say I convert to liter. I'm going to get 0.25 liters. I'm going to have this. So if I apply that here, I'm going to have molarity equal to, remember, I'm not using the 1000 here, I'm not using it. So I'm going to have the mass or the given mass or the weight over molar mass multiplied by volume. So I will have this. From here, I will have molarity to be equal to the given mass is 10. So I have 10 over the molar mass is 40. I have 40 multiplied by the volume is 0.25. I have 0.25. I have this. So if I have this is 10 here. So if I have this from here, molarity equals to, if I multiply this, so I have 10 over, if I multiply this, I'm going to get 10 as well. I will get 10. From here now, molarity now equal to 10 divided by 10 will give me 1. So I have 1 molar as my final answer. Alright, so I'm going to end this video lesson here and I will continue on a part 2 because I don't want this video to be too much of lengthy. So I'll make a part 2 video concerning the calculation on molarity. So if you find this video helpful, do also hit the like button, subscribe, and also share to those who are having difficulty when it comes to the topic of molarity or concentration. The 3 formulas that I gave you can be used to solve any question at all. Any question at all. You just know the 3 formulas offhand, just understand the molarity and know the formulas, and you'll be able to solve any question at all, any question when it comes to molarity and concentration. So thanks for watching. This is Olago Academy. Thank you.